Welcome back to AI Success Academy. This is Course 1, Lesson 4, Machine Learning Explained Simply. In our previous lesson, we learned the difference between AI and traditional software. Today, we're going one step further. We're going to understand one of the most important ideas behind modern artificial intelligence, machine learning. And don't worry, you don't need to be a programmer or a technology expert to understand it. So, what exactly is machine learning? Machine learning is a way of creating computer systems that can learn patterns from data and use those patterns to produce predictions, classifications, or other outputs. The word learning can sound complicated, but the basic idea is actually quite simple. Instead of programming every possible rule manually, we provide the system with examples and use a learning process to create a model. A simple way to remember this is data plus learning equals model plus prediction. Let's use a simple example. Imagine that you want a computer to identify spam emails. One approach would be to manually create hundreds of rules. For example, you might tell the software to look for certain words, suspicious links, unusual senders, or other characteristics. But as the problem becomes more complicated, creating and maintaining all those rules can become difficult. With machine learning, we can provide the system with many examples of emails that have already been classified. Some are labeled spam, others are labeled not spam. The learning process uses those examples to identify useful patterns. Later, when a new email arrives, the trained model can produce a prediction. But what does the machine actually learn? It doesn't necessarily learn one simple rule.
Before a machine learning model can be useful, it generally needs to be trained. Training means using data to adjust the model so that it can capture useful patterns. Think about a student practicing questions before an examination. The student sees examples, practices, and improves. A machine learning model also goes through a learning process using training data. Of course, a computer model does not learn exactly like a human student. This is simply an analogy that helps us understand the basic concept. The important idea is training data, learning process, trained model. You will hear the word model again and again when learning about AI. A machine learning model is the result of a learning process that has captured patterns from training data. Once trained, the model can be used with new data. For example, thousands of examples go through a learning process. The result is a trained model. Then a new example is given to that model. The model produces a prediction. So remember, training creates the model. Using the model produces an output. Supervised learning. Machine learning is often introduced through three major categories. The first is supervised learning.
In supervised learning, the training data contains examples with known answers or labels. For example, image, cat, image, dog. The model learns from these labeled examples. Supervised learning can be used for tasks such as classification, prediction, spam detection, and image classification. Unsupervised learning. The second is unsupervised learning. Here, the data does not come with predefined labels in the same way. Instead, the system attempts to discover useful patterns or structures in the data. For example, a business might analyze customer information and identify groups of customers with similar characteristics. This can help with customer segmentation and pattern discovery. Reinforcement learning. The third is reinforcement learning. In reinforcement learning, an agent interacts with an environment and receives feedback based on its actions. A simplified process is action, feedback, learning, better actions. Imagine an AI system learning to play a game. It takes an action, receives feedback, and gradually learns strategies that can improve its performance.
You may already use machine learning every day without realizing it. Email services can use it for spam detection and message categorization.
Entertainment platforms can use it to provide recommendations for movies, music, or videos. Online shopping systems can recommend products. Smartphones can use machine learning for speech recognition, image features, and predictive text. Search systems can use machine learning techniques to help understand queries and identify relevant information. Financial systems can also use machine learning to help identify unusual transaction patterns. Machine learning isn't limited to research laboratories. It's already part of many digital services we use every day. Now comes a very important point. Machine learning does not always get it right. A machine learning model can make incorrect predictions. Its performance can be affected by poor quality data, incomplete data, biased data, insufficient training examples, or changes in the real world. That's why we should not automatically treat every AI output as a fact. AI can be extremely useful without being infallible. Human judgment remains important, especially when decisions have significant consequences. This brings us to another important idea. Data quality matters. You may have heard the expression, garbage in, garbage out.
The basic idea is that poor quality input can contribute to poor quality results. If training data is incomplete, inaccurate, or not representative of the real situation, a model may perform poorly. That's why machine learning development can involve data collection, preparation, testing, evaluation, and monitoring. And this connects directly with our previous lesson. Traditional software generally follows rules explicitly defined by programmers. Machine learning uses data and a learning process to create a model that can then be applied to new data. That difference is one of the foundations for understanding modern AI. So, what should you remember from today's lesson? Machine learning allows computer systems to learn useful patterns from data and use those patterns to produce outputs on new data. Remember these 4 words: data, learning, model, prediction. And remember, machine learning is powerful, but it is not magic. Good data, appropriate methods, careful evaluation, and human judgment all matter.
Congratulations! You have completed Course 1, Lesson 4, Machine Learning Explained Simply. If this lesson helped you understand machine learning, consider subscribing to AI Success Academy. In our next lesson, we'll explore generative AI and understand what makes it different. Until then, learn, practice, create, grow. Thanks for learning with AI Success Academy.